Welcome to the next video in the systems programming video series. We are still in week 4 and we just finished assignment 3. Now there's this study guide, so let's take a look at this. I guess code jams maybe were some like way of doing like a quiz or something like that in class. So we may look at that, but at least let's look at the study guide and just kind of do these practice questions. What is the minimum size of the following structures? The minimum size for a struct snack is going to basically be the sum of the minimum sizes for each of the fields. It'll technically have a little bit more, it'll need a little bit more space than that because I think like it allocates space for the header information or something like that. But since we're just looking for the minimum size, and I mean like the minimum, well, I mean, in some sense, since the value of the size can be computed exactly, C does it all the time, then, we could, like, what do we mean the minimum? Well, probably what I think we mean by the minimum is simply to figure out the sizes of each of these things and then to say that the sum of them is a minimum on the size needed for snack. If we have a statically allocated char array of 30 with 32 coordinates, then that, right, each individual char consumes a single byte, so that's 32 bytes, trivially. Okay. An int is on most hardware 4 bytes, so now we're up to 36 bytes. And a float, can't remember, it says to use the size of function to check your answer. So why don't we go ahead and do that? I'm over here in the J1 because this seems related to the jams. So anyway, let's come over here, open up this border thing. Let's maybe say include standard lib and standard IO probably, yeah. And just jump into int main and say that I would like to printf percent %d the size of, and then here would go and okay, let's do a line break just for readability, the size of a float, which I do not recall off the top of my head. So let's go ahead and have C tell me. And so if I cd up a level, come over to J01, and then if I call make border, then it doesn't like it. Why doesn't it like it? Oh, I think that, yeah, so it's supposed to be like a long or something like that. So let's say LD. Now it makes, now we do dot slash border 4. Boy, that's interesting. 4 bytes, the same as an int? That can't be right. Oh, well, I guess, okay, what did we see several videos ago? That there were 23 bits for what, the Mantissa? There were, I think, 8 bits for the exponent, 1 bit for the sign. So, what it was, 20, or was it 27, 28, right? Because I think it was 27 for, or was it 27 or 23? Here, how many? uh, let's look up, like, I don't know, bits of float. So 32 bits, which if you divide by 8 is 4 bytes. So in fact, yeah, I guess that is correct. We could go through the decomposition. Is it worth going through the decomposition just to see like why, like how all the sort of arithmetic of that works out? So, okay. From 0 to 22, that's 20. Here, this is the nice diagram that was like in the book, but here it's on Wikipedia. And so 0 to 22 means 23. This is a 24th bit, and then 8 in between here. So 24 and 8 is 32, and then take 32, divide by 8, the number of bits in a byte, and you get 4. So yeah, I guess a float is 4 bytes. Okay, fair enough. So then getting back to the problem, so we had 32 and 4 is 6, 6 and 4, or sorry, 36 and 4 is 40. So a minimum on this, the size of a snack is 40. Okay, so how would you create a subdirectory using the, like a Unix terminal to create a subdirectory named foo? Let's just do this little exercise. So let's cd into, where do I have all this? No, this is not what I want. Where do they put the code? It's in the desktop, right? And let's go ahead and do what we're doing here in J01. So I've navigated to where I stored locally my copy of the course source code. And now that I'm here, I could ls if I want to make sure that I know everything that's here. Okay, that's good. Let's make dir. mkdir is the command to create a dir. So we'll create one called foo. And there it is. Now if I ls, then foo is there. You can see it in blue. Oops. So that's making a subdirectory with name foo. What if I want to see the contents of my bash rc? I think the bash rc is what, in my root directory? So I'd have to go to cd root, which is that right there. This is like, above the level of the desktop, if that makes any sense. I can ls what's here. You can see all the stuff that I have at this level. I think the bash rc file is supposed to be here. So if I say ls -a is the all flag, so it'll not just show me like normal stuff, but in fact it'll show me stuff that is usually hidden, and I get to see more, and there is the location of my .bashrc, right? .bashrc is literally, right, that dot is part of the file name. Okay. How do I list the contents of foo? So I could, even if I'm just from here, I could say ls, but then I want to list the contents of foo, which I believe I would have to go into // so that's like from the current directory, go into the desktop. From there, go into assignment main. From there, go into J01. From there, I want foo. So now if I do this, this will list everything that is stored inside of foo, which, because I have not put anything there, it will show me nothing. There it is. There's nothing. Okay. Next, we want to create a file in the directory foo called test.c. Let's just cd into foo. So let's say cd./desktop assignment main J01 foo. And then now that I have cd'd in here, I can go ahead and say touch test.c. That just creates a text file, a totally blank text file. So if I ls now, you can see the text file. And if I want to compile a C program, we've seen a million instances of that, but yeah, let's just see. Okay, so I don't even know what would happen if I tried to compile test.c. Let's find out. Yeah, exit, right, because there's no main function, so of course it's not going to like that. Or I could have predicted that. I mean, anyway, it was worth checking out just to see what would happen. Anyway, let's quickly make something that will compile. So I'm going to use Vim. Here you'll get a small taste of how to use Vim. Initially, when you open up Vim, it looks bizarre. Oh, actually, yeah, I'm in the right place. Okay. It looks bizarrely like this, and you wonder what the hell is going on. And it's a good question, because what's going on is not how most text editors are. Vim is meant to be, like, it has a lot of ways that it is designed so that you can do everything that you usually want to do without ever needing a mouse. That's kind of, why it is the way that it is. So part of that design is that you have these separate, I guess, environments. I'm not exactly sure what you call them. I mean, I'm no Vim expert, but like, basically there is like navigation, editing, right, there's visual mode or something like that. So I forget the names of the modes. But in any case, right now we're kind of like in the, I don't know what, like visual mode or something like that, which allows us to move around in the document. Right now there is no document, so that's almost like sort of silly. But in any case, from here, if you want to start putting text in, you can't just start writing your text. You have to press I, which I just did. That puts you into insert mode, and now you can start entering your text. So now I can say include standard lib, include standard IO. I will probably want those at some point, int main, and all I want to do is return 0, and there it is. The indentation on default, like, because I don't think I've configured my Vim at all, so that indentation is absolutely wild. But okay, now I just hit escape, right, on my keyboard. That's because I was in insert mode and I want to now leave insert mode so that I can do various file operations like saving this file. So if I want to save this file, then I type colon. So now that I've typed colon, it puts me at that little blinking cursor at the bottom of the window. And now I can tell it that I would like to write and quit. And if I do it like that, I'm not sure if it will like it. Let's see what happens. If I write and quit, oh, it did. It wrote and quit. Let's just double check the file is still there. If I vim into the test, what I wrote is still there. So it did write and it did quit. Here, if I want to just quit, I do colon Q, that quits, I'm back up to here. Now I should be able to gcc test.c, and it worked. And because I did not tell it what to call the output, then it'll call it just a.out. And there it is. Okay, so yeah, I guess that, right, the question was how do you compile a C program? And there you have it. That's how you compile a C program, even if you're just completely working from the terminal. Okay, so when Willow runs her program from the command line, she gets the following error. What is happening and how can she fix it? So, okay, we ls to see all the contents of the current directory. We see that it has a makefile and executable for fortune and hello. She tries to execute the executable simply by writing its name. That's not okay. To execute the executable, you have to call /. That is, honestly, do I even understand why you have to call /, except that it's just our accepted way of saying that you're going to execute a thing, right? So like, because like sometimes // means from the current directory, like, I don't know, you're going to cd over to here or there. But if you don't cd, if you simply just straight up / and then specify the program location, then it runs the program. So I'm like, that's a little bit of semantics that I'm not sure exactly how it agrees with the syntax, but maybe we'll learn later on in this class. Anyway, so that's how you run a program. Because my program does not say to do anything, then you don't see anything happen. But that, right, so if you wanted, right, if Willow wanted to run the hello program, then she would have to say /hello. Okay. Implement and test a power function for positive integer exponents only. A call to your function should compute base to the exponent and might look like this. Okay, so let's go ahead. Do I want to continue editing in Vim? Probably not. I just don't like it as much. Let's come back over to here. We've already set this up. So let's come over here and implement an exponent function. What did they say it was supposed to look like? Its name is power and it takes 2 arguments. So let's say that int power, int base, int exp. So I basically want to multiply together. The easiest way to do this is recursively. So I'm going to take the easy way out and say that if not exp, right, or yeah, if not exp, which is to say that the exponent is 0, then simply return 1. Otherwise, return power of base exp minus 1 times base. So that is not a great, right, like algorithmically, and maybe even by considering the stack, the execution stack, that's an inefficient algorithm, but it works, and that's all I care about right now. So let's say %d, and I would like to compute power of, let's say 3, 4, which 3 to the 4 is 81. So what do we get if we execute that? So let's execute 81. All right, so just went for the easiest possible, quickest implementation of power. Let's come back here. Implement a function void remove that removes all occurrences of letter from string. Should modify the contents of stir, test your function from main. Okay. I think, right, we're going to return a string, so that should be a char star. We're going to call it remove. It's going to take an input char star stir, and it's going to take a char letter. Here's my strategy for how to remove the letter from the string. I am going to basically tell it to shift all right, because like if you go through the string and you know want to like delete a letter, like you could just like replace that letter with some like empty character or something like that. But that's not exactly what we mean, right? Like what you really need to do is not only delete the letter, but shift all the letters above it or after it to the left. So how do we accomplish that? Well, let's make a shift, right? Like let's say int shift is initially 0 because I haven't found any instances of my char. But then as I progress, I will increment the shift and then progressively shift values by the shift. So let's see what that looks like. So while, oh, and I'm going to need to keep track of where I currently am in the string. And since there's no input for like the length of the string, then I probably just want to say my integer index I is initially 0, but and maybe I'll talk about like the current char, or maybe I'll just use I to always access the current char. But so what I want to do is say that while stir at I is not the null character. While it's not the null character, then what I would like to do is check what it is, and if what it is the character that I'm looking for. So if stir at I, in fact, is my letter, my input letter, then I would like to increment the shift. Once I have some shift quantity, then I would like to take the current letter and shift it down by that much. In fact, though, actually, I think maybe I want to do that right from the beginning, right? So if you think about like, what if the current character is the one I'm trying to delete, like you're trying to delete the letter A and the current character in the string is the letter A, then, you know, like I want to go ahead and start shifting down all the things by whatever the current amount of the shift is, so that by the time I get to the next iteration, the first thing that it does is it takes that letter and moves it left. So I would like to say that whatever is at the current index should be moved to the left by the shift. So that would be stir bracket I minus shift. Initially that's 0, so that intuitively doesn't cause a big problem, but I minus shift is set to the thing at stir I, and we increment I always. Actually, I guess maybe do I is this the right design? So if I encounter the thing that I want to be writing over, then maybe I want to do multiple things. So I want to shift and maybe continue because or no, yeah. So if that increase the shift, right, but I guess it's in the else case that I want to simply perform the shift. So stir bracket I minus shift equals stir bracket I. And I gets incremented. And then what we want to make sure of, right, so I think that should take care of it. We'll test it in a second. But at the very end, right, like by doing this way, because it breaks when it reaches the null character, but we want to make sure that the null character is in the correct place at the end of all of this, then we should end this by saying that stir bracket I, which is currently pointing to the place where the null character should go, we simply set that to the null character, and I think that should work, so let's test that out. So if I now say that I want %s of place in my, I need a char star because otherwise, yeah, I can't use a string literal. That wouldn't make sense. I need some variable with an address and blah blah blah. Okay, so let's say let's go ahead and say char example string, and let's statically allocate whatever 32 characters. And then I would like to, and let's say that what is in there is the string hello, and I would like to eliminate the letter, let's start with E and then L. So for now, let's say example, the letter E. Let's see what that does. Oh, did I? Wait. Oh, I didn't return, and ooh. So I should return stir. Extern in, I think maybe there's like some other thing that is also called extern or remove. There's no header file. What? Oh, yeah. Declaration is incompatible with int remove. Okay. So what did the assignment say? Yeah, it wants it called remove, which, I mean, let's make that happen. C override name conflict. Maybe I'll just, okay, fine. So let's just call this for the jam. And then if I come down here and say that this is for the jam, then I wonder if that resolves everything. Sure seems like it. Didn't print nothing, so that's not what I wanted. There, okay, now that's not right, so I clearly have a bug, but at least it's printing something. So when I see the E, right, so I see H, shift is 0, nothing happens. I come back around and I see that now the string at index I is E, which is my letter, so I increment the shift and I update the shift, but then I only update the index and move along to the next index. Now, when we get here, stir I is L. That is not equal to my letter E. And so, right, and so what I should do is take the L and copy it over to the left, and that's exactly right, and that's why I see this right here. So that is, in fact, quite good. Oh, yeah, the only problem seems to be that final O, right? So I just have more O's than I want. Oh no, because it reaches. Right. It reaches. I should probably put this with the shift. Yeah, that's what it is. This also needs to go left by the shift. Okay, let's try that. There it is. Now, if we switch this to L, does it still work? And yes, it does. So there it is. Okay. So this is a long video. Maybe I'll break this up and continue the rest of the problems in a second video.